Hello. Many of you might be familiar with the concept of 6 degrees of separation. This is the idea that anyone is separated from anyone else in the world by only 6 handshakes or 6 friendships. Many researchers have tried to validate this idea, and it turns out that although the number 6 isn't quite correct, it's near enough. This just goes to show that we live in a highly interconnected world. One example of this is shown in the image behind me. This is a visualization of Facebook's network of contacts. It's just one example of what mathematicians like to call a graph or a network. Other examples of networks include the London Underground, the internet, and the vast network of neurons inside our own brains. In my PhD, I'm studying mathematical models of networks. The specific problem that I'm working on is often that we know there's a network of contacts, but we don't know what the connections actually are, or who is talking to who. And unfortunately, this is going to be the case even if we persuade Facebook to hand over all the data they have on us, which is of course a little bit of a privacy violation. So, how on earth can we predict the connections? In my PhD, I'm using a mathematical model known as a random geometric graph. A random geometric graph looks a little bit like the image you see behind me. We start with many points scattered across the plane, and then we connect points which lie closer together with a higher probability. Using data from social network studies, we can attempt to come up with a mathematical function that tells us the probability of any 2 individuals sharing a connection. And this function might also include factors such as people's ages and their social background, which will allow us to better predict some of these tricky long-range links that you might also see up there. So why on earth would we want to do this? Well, it turns out living in a highly interconnected world does have a few downsides. If patient 0 of the next Ebola-like epidemic is only 6 handshakes away from me, then perhaps I should start to get a little bit worried, and maybe you should as well. Understanding the mathematical properties of models such as random geometric graphs allows us to better predict and control epidemics such as Ebola. And the same maths can also be applied to other epidemics, such as the epidemic of fake news that we've been seeing spread through online social networks recently. So I hope in this short time I've convinced you that studying the mathematics behind random graphs has many important and exciting applications. Thank you.